Today we will discuss about feedback and effects of feedback. Feedback is actually the process of taking a sample of the output and feeding it back to the input side. This feedback actually helps our closed loop control system to do the automatic correction in the output. So that's why we say the closed loop control systems are accurate. They can do automatic correction in the output because of the presence of the feedback. But this kind of feedback has certain effects on the system. So now we are going to discuss those effects. Firstly, we will discuss the effect of feedback on the overall gain of the system. Here you can see a closed loop control system. So we have a system with the gain G. Gain, or sometimes we use the term transfer function. So sometimes you can see that instead of G we have used G of S domain function, G of S, or simply we can use G. Okay, so this is a open loop system, this G alone. If we are using G alone, then it's a open loop system and the overall gain would be G. But here, to that particular system, we have added a feedback element with the gain H or H of S. So now we have a closed loop system. The gain in the forward path is G and the gain in the feedback path is H. Okay. So without feedback, without this H element, the gain would be G alone. But what will happen when we add a feedback with an element having gain H? Then what happens is that the gain will now become G divided by 1 plus GH. This is very important. Okay. So sometimes we have to use this expression in doing problems. So now the overall gain of the system or the transfer function, it is nothing but output by input. So Y is the output, R is the input. So output by input, Y divided by R. It is the overall transfer function or the overall gain of the system. M is equal to Y by R, which is equal to G by 1 plus GH. So when we add a feedback, the initial gain G has now become G divided by 1 plus GH. That means the gain has now reduced. Okay. How will we get this G by 1 plus GH? We will discuss it now. So this is a simple representation of the above system. We have a system with the gain G in the forward path, and we have taken a feedback from the output, and in that feedback path we have a feedback element with the gain H, and the output of the feedback element is applied to a error detector. Also we are applying the input R to the error detector. See, here you can see plus minus. Okay, this minus, at the bottom point of the error detector we have a minus symbol. This minus actually indicates that the feedback is a negative feedback. If in this error detector the symbol was like plus over here, where we apply the input R, and plus here at the bottom point of the error detector where the feedback signal comes, then the feedback is a positive feedback. So please take care of that. At the bottom point of the error detector where the feedback signal comes, we have a minus over here, which indicates that the feedback is a negative feedback. And if this symbol is plus, that means the feedback is a positive feedback. Okay. So we are applying input R to the error detector, and C is the output. Okay. G is the gain of the system in the forward path, and H is the gain of the system in the feedback path. Okay. So here from the output we are taking a feedback. So the signal is C is taken and is applied to the feedback element with the gain H. So definitely the output of this feedback element will be C into H. So we have CH over here. This CH is applied to the error detector. Since it's a negative feedback, we have a minus over here. So what will be the output of this error detector? It will be reference input R minus CH. If this symbol was plus, then this would have R plus CH. But since this is a negative feedback, the output of this error detector is input R minus the feedback signal CH. Again here this R minus CH signal is applied to the element with the gain G. Then obviously the output of this element would be R minus CH into G. So that is our final output C. Okay. So now we have C. Output C is equal to R minus CH into G. So that is equal to, so we are multiplying with this G, RG minus CHG. So we have C is equal to RG minus CHG. So now we are bringing the C terms together. So we have C plus CHG is equal to RG. So C is common here. So we are taking C outside. C into 1 plus GH is equal to RG, which implies the overall gain or the overall transfer function, which is equal to output divided by input. So C by R. From this expression, what is C by R? C by R is equal to G by 1 plus GH. So this is how we get the overall transfer function of the above system as G by 1 plus GH. It is very, very important. Please keep in mind. Okay. So that is the effect of feedback on the gain. Okay. So now what is the effect of feedback on the stability? So we already saw that the overall transfer function is G by 1 plus GH for the above system. But what will happen if GH is equal to minus 1? If this G into H is equal to minus 1, then this will become G by 1 plus minus 1. So here the denominator we have 1 minus 1, 0, and gain becomes infinity. If gain becomes infinity, then that particular system will become unstable. So now to make the system stable, we need to introduce another feedback loop into the system. So this is how we are going to add the second feedback loop. So we have this G and we have a feedback with the feedback element H. Okay. In that particular system, if GH equal to minus 1, then the gain would become infinity and the system will become unstable. So to avoid that particular condition, we have introduced a second feedback loop with a feedback element having gain F. So if such a feedback loop is introduced in the system, the overall gain will change and now it will become G by 1 plus GH plus GF. So now even if GH equal to minus 1, there is no issue because we have a term GF with the denominator, and this GF will ensure that the denominator part is has never become 0. Okay, so this is how we can make a system stable in a simple sense. Okay, so that is the effect of feedback on stability. So we can make a system stable by introducing another feedback loop. Okay, now the third point is effect of feedback on sensitivity. So sensitivity is equal to percentage change in M, where M is the overall gain or overall transfer function of the system. So percentage change in m divided by percentage change in g. So dou m by m, that is the percentage change in m. Dou m by m, that divided by dou g by g. So I can rewrite this expression as dou m by dou g into g by m. So this expression is same as dou m by dou g into g by m. Okay, so now we are going to calculate each term. So we have the overall transfer function m is equal to g by 1 plus gh. So now you find out what is dou m by dou g. You just find the derivative of m with respect to g. So how will you find dou m by dou g? So we need to find the derivative of this g by 1 plus gh with respect to g. So it can be easily calculated as denominator into derivative of the numerator minus numerator into derivative of the denominator whole divided by denominator square. So if that is the case, then dou m by dou g is equal to 1 plus gh into 1. Derivative of g with respect to g is 1. So 1 plus gh into 1 minus g into h divided by 1 plus gh square. See, this is the answer. 1 plus gh, this is the denominator. So denominator into derivative of the numerator, that is 1, minus numerator g into derivative of 1 plus gh with respect to g, it's h, divided by denominator square. So if you simplify this, you will get 1 by 1 plus gh square. So this is dou m by dou g. So now we need to calculate g by m also. So then only we will be able to find out the sensitivity. So here we have m is equal to g by 1 plus gh. If that is the case, then what is g by m? So g by m will be 1 plus gh itself. Okay. The sensitivity is equal to dou m by dou g into g by m. So we have already calculated dou m by dou g, which is 1 by 1 plus gh square into g by m. So just now we have seen that g by m is equal to 1 plus gh. So it's 1 plus gh. So 1 plus gh will get cancelled, and what is remaining will be s equal to sensitivity equal to 1 by 1 plus gh. Okay. So that is the sensitivity with feedback. Right. Now fourth point. What is the effect of feedback on external disturbance or noise? See, here we have a system. This n is the noise. Let's see. Okay. So if there was no feedback, and then the output due to the noise n acting alone would be G2 into n. So take a case where we don't have any feedback, and what would be the output y, which is due to this n alone, which is due to this noise alone. So that y will be definitely n into G2. Now what will happen if we insert a feedback into this system? So when we add this feedback, what will happen to y? So y will now become, y is equal to n into G2 divided by 1 plus G1 G2H. So now by adding the feedback, our final output y has now become n G2 by 1 plus G1 G2H. That means the effect of noise has reduced. So initially it was ng2. Without feedback it was ng2, and now with the presence of feedback, y is equal to ng2 by 1 plus g1 g2h. So the effect of noise has been reduced.